I would like to invite Dr. Thomas Leppin to this section of our workshop. First, I would like to thank you for accepting our invitation to join us and to deliver this talk for us. So I will give you a brief introduction about him. Dr. Leppin, he completed his doctoral degree from Justice Leibniz University in 2007. That's from Germany. And then currently he is working for Compo Expert, and this group of company is specializing in all type of fertilizers for the crop needs, including biostimulant range of products. And currently he's also a member of the EBIC, that is the European Biostimulant Industrial Council, which is trying to lobby and to bring a regulatory framework for a biostimulant range of products in Europe. So Dr. Leppin, the floor is yours now.
Yes, many thanks, Sujit, and many thanks also to you, Mr. Feuerstein, for the opportunity to give you that speech here today and for the invitation. Yes, I'm basically here today on behalf of EBIC, the so-called European Biostimulants Industry Council. And this is who I will speak for today. So of course, in my regular life, I work for the company Compo Expert, which was briefly introduced a few minutes ago. But today I'm here as member of EBIC and as such as one of the directors at large at EBIC, and in the role as a regulatory expert in the frame of biostimulants. So my topic today is to give you a little insight into the, let's say, the regulatory landscape of biostimulants, which is quite complex, I would say, at least in terms of fertilizing products, which they now belong to. But let's take a look into what I will show you today. First of all, I will of course give a little insight into what EBIC is and the goals of EBIC. Then I will speak about the fertilizing products regulation, since that is the main frame of the biostimulants regulation today. Show you how the fertilizing products regulation gives us a different path to place products on the market. We will also have a little insight into the role of the SEN standards and what that is, and we'll see what the FPR provides us and what it does not provide to us yet. And of course, we'll give you a little, or I will give you a little overview of EBIC's key priorities. First of all, EBIC, the European Biostimulants Industry Council, has currently 71 member companies. And this is quite equally spread through micro units, let's say, size-wise, small, medium, large, very large. All these companies are quite equally represented within EBIC. And the general mission of EBIC is, of course, as an association, as an industry association, to ensure that biostimulant technologies are valued as integral to sustainable agriculture while securing and enabling regulatory framework for all of them. We will look into what biostimulants are, what different kinds of substances are summarized under the term of biostimulants, and you are also aware what other technologies are part of sustainable agriculture, be it plant breeding, fertilization, or also plant protection. And we, of course, want to ensure that biostimulants are considered also as a part of that, what you consider sustainable agriculture. I'm sorry, I had a little cold, so when my voice is still a little rough, that is the reason. Yeah, on EBIC's history, EBIC was founded in 2011. Then the first meeting took place of, at that time, only 10 companies that founded EBIC together at that time. In November 2012, then EBIC was already set up and sponsored the first World Congress on Biostimulants. At that time, biostimulants were still very small topic, let's say, but increasing. In 2013, EBIC launched then its code of conduct, which all members of EBIC have to adhere to. And even today, that is still the case. And in 2016, plant biostimulants were for the first time included in a regulatory draft proposal. That was the Fertilizing Products Regulation at that time. And PFC, you will see that later, that abbreviation more often. That stands for Product Function Category, and that is how the Fertilizing Products Regulation is structured. You have these product function categories, and there biostimulants were the first time ever in any kind of regulatory framework included in the European draft of the Fertilizing Products Regulation. Then, of course, another cornerstone here was June 2019, when finally the FPR was published in the official journal after political agreement between the European Parliament and the Council and its formal adoption. But that was only, you see, 2016 was the first draft, 2019 it entered into force, basically, and only in 2022, and this is what you see on the right-hand side, it really entered into practice. So only from 2022 on, you could really bring products into the market according to that legislative framework. So that took all in all more than 10 years to bring that new regulation into action. And in 2020, what I forgot to mention here, of course, EBIC helped to launch the first Farm to Fork Europe conference, which is now gaining attraction. Okay, then, next slide. What are plant biostimulants? By the way, what just comes to my mind, if you have questions in between, if you want to know something or more specific answers to whatever I present here today, just stop me or just ask in between. I do not see raised hands here if you raise your hand, but just yeah, jump in and ask whatever question you have, if there are any. Okay, what are plant biostimulants? Basically, plant biostimulants are defined by their function rather than by their composition. That is different from many other products which are defined by what are they composed of. But for plant biostimulants, we always look at the function, and this definition is completely in line with what EBIC always advocated for, and what you find today also in the Fertilizing Products Regulation. We will, with the next slide, we will look at the definition as it is written in the FPR. But for now, let's take a look at the picture you have here. Basically, plant biostimulants, they can have different functions. They can, for example, enhance growth and stress tolerance of plants. You see that on the left-hand side. in the function, in that function, for example, you find different products, like, for example, algae extract, protein extracts, humic acids, fulvic acids, and all of these substances have a certain ability to help plants tolerate stress or help them enhance their growth. We have products, for example, on the let me just, maybe you see the mouse when I go here. Yes, you probably see. When you for example go for the soil microbiome, microorganisms are also considered plant biostimulants, and microorganisms help plants very often to improve the nutrient uptake or enhance the nutrient use efficiency within the plant. Or we have, abiotic stresses which negatively affect crop productivity and growth. And such abiotic stresses are, for example, excessive precipitation, high temperature, chilling, drought, or salinity, or many others. And all of these can, of course, be alleviated by using plant biostimulants. You also have better crop quality and maintain or improve yield. That is also something which plant biostimulants can contribute to. Just to give you a little insight or a little overview of what plant biostimulants are considered. And these substances are then put into formulation which are used to obtain one of these beneficial effects on the specific target crops. But let's look into the definition of plant biostimulants. A plant biostimulant, this is also as it's written in the fertilizing products regulation today. Plant biostimulant means a product stimulating plant nutrition processes independently of the product's nutrient content, with the sole aim of improving one or more of the following characteristics of the plant or the rhizosphere. And these are the four that are mentioned also in the regulation. First is nutrient use efficiency. So plant biostimulants can be used in order to improve nutrient use efficiency. They can be used to improve the tolerance to abiotic stresses, to improve quality traits, or to improve the availability of confined nutrients in the soil or rhizosphere. These are the four general claims that can be made in conjunction with biostimulants. But of course, in order to being able to claim such a message on the label or on any other product, you have to do, or you have to prove that the claim is really true. But that is something I will come to later. For now, let me just also tell you that the plant biostimulants are the so-called PFC6 within the fertilizing products regulation, which I said earlier. PFC stands for product function category, and biostimulants are the so-called PFC6 and subcategorized into PFC6A, which is microbial plant biostimulants. That might be a microorganism or a consortium of microorganisms, which is referred to in the so-called CMC7. CMC stands for Component Material Category 7. We will take a look into that. I think with a well, not the next, but the slide afterwards. The second is PFC6B, that is non-microbial plant biostimulants, and that comprises everything which is, for example, algae extracts, humic acids, fulvic acids, amino acids, and also chemical substances, which some people do not have in mind when they think about biostimulants. All right. Then the fertilizing products regulation. Let's take a look into what the fertilizing products regulation is. The regulation has the number 2019-1009. This is probably something which is not so important for many of you, but this is something I can already tell you when you wake me up at night during my sleep. I know this number and the whole regulation by heart. It was adopted on 5th June 2019 and was applicable as of 16th July 2022. And just three important points in conjunction with that regulation. It follows the principle of the so-called optional harmonization. So all manufacturers can choose if they want to declare or bring their product into the market under the frame of the Fertilizing Products Regulation, FPR, or under their national rules. They always have the choice. Basically, many producers or manufacturers would really love to have not the optional harmonization, but the mandatory harmonization, which is let's just go for one legislation and that's it. But that was probably not doable with one or the other government of one of the member states of the European Union, which makes things much more complicated with many different regulatory frameworks which you can choose from. Then the second point here regulates placement on the market, not the use. This is what the FPR does. And the third point, the FPR leads to CE marking, which means with the CE marking, which most of you probably know, you have the CE marking on many products of your daily use, of your daily routines. You find that, for example, I have my mouse here, for example. I don't know if you know, you probably can't. Yeah, so this way you can see it. There's a CE mark on my mouse even. You see that on your mobiles, you see that on probably your fridge or whatever. Everything has a CE mark today. And that means basically all these products go through the same general frame of regulating things within the European Union. And with that, CE marking products are generally free to move in the EU single market. And that is also what the fertilizing products regulation can do for all fertilizing products, including biostimulants. So it is in the interest of most manufacturers to gain that CE mark in order to bring their products easily into the EU single market and not being dependent on the national frameworks to bring their products into the market. But of course, this is not so easy to accomplish. There are many things which have to be considered and done before being able to put the CE mark on a product and bring the product into the market. And let's just go through some general rules from the Fertilizing Products Regulation. Because first of all, or let's say an EU fertilizing product, before being able to enter the market, has to meet the requirements for a product function category. And that is the term I mentioned several times today already, product function category. This is what you find in the so-called Annex 1 of the Fertilizing Products Regulation. And there are currently 7 product function categories, starting with PFC1 fertilizers, which comprises organic fertilizers, organomineral fertilizers, as well as inorganic fertilizers. Then PFC2 liming materials, PFC3 soil improvers, PFC4 growing media, PFC5 inhibitors, which comprises, for example, nitrification inhibitors or urease inhibitors, PFC6 that is, of course, for us, the most important one, plant biostimulants. And as I told you, subcategorized into microbial and non-microbial plant biostimulants. And finally, PFC7, fertilizing product blends. But also PFC7, let me say that honestly, is a very important product function category, because here you can really put products in that are a combination of either of the ones above. So you can combine an inorganic fertilizer with a biostimulant, or you can combine liming material with for example, a soil improver or whatever. That is what makes the fertilizing products regulation quite interesting, because you have much more opportunities and possibilities than you ever had before in the frame of the fertilizer regulation as it was before. In the old fertilizer regulation, you always had fertilizer types, and you could only bring these fertilizers into the market, but not any other innovative substance. And now you have, beside those organic fertilizers which you had in the past in the regulation, you have now also organic materials, recycling materials, biostimulants, growing media, all these things which were never regulated on European level. Okay, that is the product function category, and it means you always have to choose when you want to develop a product, okay, which function shall my product have? Does it have a biostimulant function? Does it have a fertilizing function? Does it have a function as a soil improver or whatever? And then you have to define that and see that you go through the next steps, which are, for example, that your product has to meet the requirements for a component material category. These are the so-called CMCs, which you already see below. There are currently 15 CMCs with many, many different raw materials, because this is nothing else but raw materials. You first have, as I said, to define which function your product has or shall have, and then afterwards you have to see, okay, what can I put into that product out of the whole range of different CMCs you have? And the ones which are important for plant biostimulants are mainly the ones listed here: CMC1, virgin materials, substances and mixtures; CMC2, plants, plant parts or plant extracts; CMC6, food industry byproducts; CMC7, microorganisms; CMC10, animal byproducts; and CMC11, industrial byproducts. And these are, of course, quite complex categories, and you probably cannot really see now what products that might be. For this, I can give you a few examples. For example, virgin materials, substances and mixtures. These are basically, these can be raw materials which you dig directly out of the earth, or like rock phosphate. That would be a virgin material substance that has a REACH registration, but is a material which was not changed in a way, or products that are created by a chemical process, such as ammonium sulfate or others. These are CMC1 materials that are produced for a certain purpose, chemical production. Plant parts or plant extracts, that is quite self-explanatory, I think. For example, everything that goes into algae extracts falls into that category, plant extracts. Food industry byproducts, that is quite limited. That is, for example, what is it? Molasses, for example. Molasses from sugar beet. That would be categorized in food industry byproducts. Microorganisms is once again quite self-explanatory, although there's a positive list in the FPR with microorganisms that can be used, which is very, very limited. There are currently only 4 microorganism strains on that list. byproducts, that these are products according to the so-called animal byproducts regulation on European level. But that does not work yet. I will also give you more insight into that later on. And industrial byproducts that are basically products that that happen to be produced not on purpose, but as a side, as a byproduct, while producing something else. There's a new category also covering such products. And these are the ones which are usually also used in production of plant biostimulants. So when you have these all on your list, the PFCs, the CMCs, you have all that covered. Then you of course still have to have a label for your fertilizing product, and there are quite extensive labeling requirements in the FPR, which you have to follow. And the fourth pillar here is then finally you have to pass a conformity assessment procedure. So product function category, component material categories, labeling, and finally conformity assessment procedure. And this conformity assessment procedure is once again, it's the final step, but it's once again a quite complex step, which you have to follow. We can see that on the next slide. There are, in order to do conformity assessments, 4 different modules defined in the FPR. And you have to choose a module for your conformity assessment based on the complexity of your product. And this complexity, of course, depends on your product function category and your component material categories. I don't want to make it too complicated. If you think, okay, that is sufficient, we don't need that, please stop me. Or I will go a little into that, but I will try not to give you too much detail and not go too deep into that. You know, I'm still on the surface. But still, let me know, just let me know. So for example, for quite simple fertilizers, not biostimulants, but fertilizers, you very often have to go through the so-called module A. And for module A, which you see in green on the left-hand side, you never need a note in so-called notified body. For conformity assessments, which are more complex, like the ones starting with A1 or B plus C or D1 on the right-hand side in yellow, you always need a so-called notified body. And these notified bodies are generally certification companies. And these certification companies have an accreditation to do these conformity assessments. When you now look into that, for example, modules B plus C or D1, these are the ones that are necessary for plant biostimulants. You see what is written here for module B plus C, PFC 1 to 6, if composed exclusively of one or more of CMC 1, CMC 2, 4, 6, 7, 8, 9, 10, and or 11, PFC 7. Just for you to understand how to read this. You always have to take a look into this and say, okay, my product, for example, as a plant biostimulant is a PFC 6 plant biostimulant. And I want this function to be represented on my label, PFC 6. Then I'm okay here with module B plus C because it covers PFC 1 to PFC 6. That is already good. But then it says, if composed exclusively of one or more of the following, CMC 1, 2, 4, 6, etc., etc. When you now, for example, have a CMC 3, which is compost, I think, if you have such a substance in your product, then you already realize, okay, that's not possible with module B plus C. Then you have to move to module D1, for example, which covers CMC3. So this is how this works. So you always have to look into, okay, what function does my product have and what is it composed of? And following that, you have to choose the right module for the conformity assessment of your product and can see, okay, do I need external conformity assessment by a certified, by a notified body, or can I do this on my own? So that brings a little more complexity into that. But if you study it properly, you will be able to do this. So I don't want to go deeper into this. I hope this is kind of clear, and then I'll move on. If you have questions, just let me know. Yes, what you see here now on this slide is once again the module B plus C, let's say. What I just told you about module B plus C, there's a reason why this is called B plus C, because it's this module is composed of two sub-models, let's say. And the one of them, the first of them is the type examination by the notified body. That means that would be module B. What you have to provide to the notified body is a description of the formulation of the product, for example, the list of ingredients. Where appropriate, you also have to deliver information about the raw materials, that is the CMCs, as I told you. You have to provide the list of harmonized standards or a list of analytical methods you use in order to analyze your products. You have to provide test reports, including efficacy testing, and this is what you have to do. I mentioned that in the very beginning that for plant biostimulants, you always have to prove via trials what you want to claim on your label. Maybe you want to claim my product increases tolerance to drought stress in tomato. Then you of course have to have trials available, which you did, and which prove by significant differences that your product really works in drought situation. So the tolerance to that drought is increased in your tomato plants. So this is also something you have to provide to the notified body. You have to provide product samples. You have to provide other supporting documentation. And then the notified body will check all this and finally, hopefully, grant the CE marked to your plant biostimulant. On the other hand, as a manufacturer, you still have to follow the so-called internal production control. And this is what you see on the right-hand side. So you have to take over monitoring and control of your production and your product to ensure that the products are in conformity with this approved type. That means, of course, the notified body will once do the conformity assessment on the type of product you produce, you bring into the market, but they will not do a surveillance of your product. This is what you as a manufacturer are then responsible for by yourself. And the second point here, you are responsible then to put the CE mark on your product packaging. This is also what you are then obliged to do if you have the CE mark granted by the notified body. So that's the path. On the left-hand side, you basically see module B, on the right-hand side module C, and that makes it module B plus C for the conformity assessment of plant biostimulants. So when you now look at the FPR, as I just explained to you, how it generally works without going into too much detail, and you just try to compare that to other kinds of regulations, in this case, for example, the Plant Protection Products Regulation, abbreviated here as PPPR, compared to the FPR, you see that in the FPR on the right-hand side, you have the conformity assessment conducted by private entities, the certification companies. They are privately owned, and they get accredited, and they can do this conformity assessment. In the PPPR and for plant protection products, for example, this is conducted by a government authority, so that is not privately done. That is one of the big differences between that regulatory frame compared to other regulatory frameworks. Then in the FPR, you have standards that are elaborated by transparency, consensus of relevant stakeholders, and after approval according to the CEN process. While in the PPPR, you only have, or not only, you have guidelines and requirements defined by government authorities. So once again, that is different. And I already can tell you here, these standards in the FPR, they are not obligatory. You can use them, but you do not have to use them. That is, of course, different for the plant protection regulation. There, everything which is there is obligatory. Then you have in the FPR legal responsibility for the product and its effect remains solely with the manufacturer and with market surveillance, while for the PPPR, legal responsible for the product falls on the government authority once the product is authorized and registered. So they can say, okay, this is still allowed, this is forbidden, please take it from the market or whatever. But if we once, according to the FPR, have our CE mark, then we are responsible for the conformity with that regulation. And finally, under the FPR, the EU Declaration of Conformity justifies that the manufacturer has presented the necessary paperwork to show that the product meets requirements and performs the functional claims, while for the PPPR, the authorization registration number justifies that the manufacturer has presented the necessary data for the product to be assessed by the authority, and the product complies to the requirements and defined by authorities. So this is just to show you the difference here between more restrictive regulations and the FPR, which already gives us quite some freedom. And now let's take a look into the standards a little more, what these CEN standards are, what CEN is, and how that can help us in the process of product conformity. Basically, as long as you do not object or interact with anything I tell you, I will just go on and try to explain what I think is necessary. I'm not sure if you know what CEN is, so let me just briefly explain that to you. That is, even if the single letters do not fit in, but that is the European Standardization Institute. The letters are a French abbreviation, I think, but that is similar to other national mirror committees, which you probably know. I just know the one in Germany, which is called DIN. You probably know better also for your respective countries how they are called, but on European level, this is the European Standardization Institute. And this institute develops standards, norms, in order to provide guidelines for testing, for analysis, for doing trials, which make life much easier for laboratories, for comparison reasons, and also for surveillance needs. And in the FPR, there are of course many limits, many values, contamination, contaminants, for example, specified that you have to be below a certain level for. And for these, you of course need certain methods for analysis, for example, or for doing the trials. You need to have a guideline for the conduction of trials. And here the European Commission in 2019 gave a contract to CEN in order to develop standards to demonstrate efficacy of biostimulants. And specifically for biostimulants and for the development of these standards for biostimulants, there was the so-called CEN Technical Committee 455 constituted. And in this CEN Technical Committee, TC 455, you have 5 working groups, basically. The first working group, WG1, deals with sampling, the second one with claims, the third one with pathogenic and non-pathogenic microorganisms, the fourth with other safety parameters, and the fifth with labeling and denominations. But for us, of course, the second one, claims, is the most important. Because, as I now told you several times, we have to go through, or we have to prove the claims we make on the labels for our plant biostimulants. That means we have to do trials, and with these trials, we have to prove significantly that with the biostimulant, a certain parameter gets better with the biostimulant than without the biostimulant. And the CEN TC455 has developed 31 technical specifications for plant biostimulants in the FPR so far. And as you can see in the timeline above, these technical specifications were developed then from end of 2019 until 2022. In March 2022, these technical specifications were published. And out of these technical specifications, the CEN further develops the European norms. This is what you see then from September 2022 on, circulation of a first draft of the European norms, EN. And now we are currently in the inquiry period for the European norms. And if everything runs smoothly, then in April 2024, we will finally have European norms for the FPR. And that then also includes, we will have standards for doing the trials in order to claim, in order to prove the claims we want to make for biostimulants, and which are then an integral part of the conformity assessment. And what are these claims? What are these technical specifications we work with in WG2? These are general principles. That is the first one. Then followed by the second, nutrient use efficiency. That these are basically, as you already see, they are identical with the general claims you can make for biostimulants according to the fertilizing products regulation. Nutrient use efficiency, tolerance to abiotic stress, determination of quality traits, and availability of confined nutrients in soil and rhizosphere. So these 5 standards are now still being finalized. and they are now transformed then into final European standards. So now, now looking a little into these standards, I explained to you already, and I hope that was comprehensive enough, that we have to conduct these trials with our products in order to have trial results, which we can then hand over to the notified body so he can finally assess our products for conformity and see if they really deliver what we claim. And in the general principles, you see the crop groupings you see here now on the screen. Broad acre crops, like, for example, cereals, oilseed, pulses, etc., woody perennials, like fruit trees, nut trees, berries, and so on. And the third one here, the third grouping is vegetables, ornaments, aromatic, and medicinal plants. That is a distinction which is made in the standards, not in the FPR, in the standards. Because you have to do your trials. You can do your trials then for one single crop, of course, but you can also say, okay, I want to go further and I want to do a trial for a whole crop group, so I can bring my product into the market for application in one whole crop group and not only for one crop. Or I can even say, I want to bring my product into the market for more than one crop group, for two crop groups, or even for all three crop groups. But then you have to do more trials, of course. So for one crop, you have to do like 3 trials in that specific crop. But if you go for more crop groups, then you have to do like 6, 8, 9 trials in order to prove that your product works in all of these. And looking a little deeper into that, at least on a lighter level, let's say, for claims justification, you have, for example, if you want to prove a certain claim, let's say, I want to prove that, as I said earlier, maybe this time we take cucumber, no, let's take apples. Apples, I think it's a good, because there we have a nice quality trait, which we can also prove. You have the quality trait of red color. Your apples shall be red, and this is your quality trait, your goal. And you have a product which improves the red color in apples. You want to prove that for fruit trees, but you maybe the same let's say, red color is now not a good example when we have this here, because we have broad acre and fruit trees. Let's see. Let's say improves the rooting, improves the number of roots in your crops. That is your claim. It improves the number of roots in your crops, and roots you have in broad acre crops as well as in fruit trees. So then you have to do like 4 trials in broad acre crops and 4 trials in fruit trees. But each two trials in wheat, for example, 2 trials in oilseed rape, then 2 trials in apples and 2 trials in berries, in order to prove that claim. Right? That is the first step, followed by the experimental design. So you have to have the experimental design set up in a way that you have a treatment with a plant biostimulant at a certain dose, which is, for example, X, and you have a treatment with a plant biostimulant at a dose Y, and you have to have a control in order to prove your claim in the trial. And then, of course, if you do a trial with with stress, which is also possible in case you want to prove a claim on abiotic stresses. Then you have to have a certain stress marker, of course. And for others, you use agronomic markers, like, for example, root biomass, which fits to our example. That is the third step. And finally, when you have your trial results, you have to do statistics. And as I said, you have to prove that your biostimulant has an advantage towards using no biostimulant. And you have to have a significant difference. And for field trials, that difference between treatments is at the 85% confidence interval. Sorry, I'm speaking too much. This is even more narrow for trials under controlled conditions. There you have 95%, as far as I remember. Okay, and finally, you have to draw up a report, and this report is what you hand over to the conformity assessment body, to the notified body, together with all your documents on PFCs, CMCs, your label, trial reports, etc., etc. This is what you hand over. All these documents, you call them technical documentation, and with that technical documentation, you can go through the conformity assessment, hopefully. Yeah, what happens in the absence of a technical specification or a harmonized European norm, this is what the abbreviations above stand for. Let me just put all of that on the screen. Generally, these harmonized standards, when you use them, they provide a presumption of conformity. So they give you kind of safety. But as I said earlier, they are not mandatory. So the regulation, the FPR, says you can use them and it's advised to use them, but it's not mandatory. You can use whatever you want, but then you're of course in a position that you have to try and convince the notified body that your trials are as good as trials which were conducted according to the standard. So in practice, that gets very difficult, let's say. Yeah, and as I said, in those cases, manufacturers need to demonstrate that the results are reliable and reproducible, explaining why the method is appropriate. This is what I just said. Notified bodies will ultimately decide whether the plant biostimulant function has been sufficiently demonstrated or not. So that is not in the hands of the manufacturers then, but in the hands of the notified body. Yes, what the FPR application has provided. Some plant biostimulants were able to access the EU market starting on 16th July 2022. That were, of course, companies that were well prepared, have all documents already available, have all trials done. They have, if these companies manage to have all the component materials listed in the FPR, I told you earlier that, for example, animal byproducts, you have no chance to get them in currently. I will give a little more insight into the reasons in the next 3 minutes, I think. But if you manage to have all component materials listed, then you are lucky, and you can go for conformity assessment, or you could go for conformity assessment already. If you obtained all relevant REACH registrations, that is also something which is very important for some of these CMCs, that you have them. If you don't have them, bad luck. That is also the case for many manufacturers today. They have products, or let's say components in their products that are not REACH registered today, since the FPR goes beyond REACH even in some instances. So that is problematic. I will also give you an example in the next slides. And if you could demonstrate the plant biostimulant effect according to the technical specifications or equivalent, then you're also lucky. and you're able to pass the conformity assessment procedure. But for many people and for many companies, that was not yet due to difficulties and the complexity of the whole regulation. And here are some of the examples which make life difficult for plant biostimulants today. For example, as I mentioned already, the animal byproducts regulation, that is CMC 10. There are no animal byproducts today that are allowed to be used in fertilizing products, and of course, especially in biostimulants. The problem is that the regulation says that the Commission has to develop endpoints, so-called endpoints. And endpoints means the European Commission has to define when an animal byproduct is not considered an animal byproduct anymore, which means not a waste anymore, but a product. And this is quite difficult because that is not only in the hands of the so-called DG GROW within the EU Commission, but also in the health part of the Commission. And for them, it's difficult to say, okay, this is not dangerous anymore, so you can use it. And so first, on European level, they have to find an agreement on which way to proceed and how to proceed. That means we already have this regulation in place, which says you can use animal byproducts for fertilizing products or for biostimulants, but in practice, it doesn't work because the regulatory frame around the FPR is still not in place. It's still not working properly. That is the problem here. And the development of these endpoints is really slow, and there are still many steps to be taken until we can really get further here. Then the second point, only 4 microorganisms are allowed to be used in microbial plant biostimulants. That is the positive list I already mentioned. And for all other microorganisms that are currently being used in plant biostimulants, the products have to be brought into the market under national rules. In that respect, the optional harmonization is a good thing. Because we couldn't bring these innovative, interesting products into the market under the FPR currently. The Commission is also still working on developing criteria to check whether a product, whether a microorganism is safe enough, has a certain agronomic efficiency, which makes it interesting for the FPR. All these things are still under development. So an assessment of microorganisms can be done. Then third point, phosphites. Phosphites are not covered by the FPR today, so they are excluded from the FPR. But they have demonstrated that they have an impact on nutrient use efficiency. We have scientific data which underlies or underlines the fact that they have a biostimulant function. Still, it's an ongoing discussion with the European Commission and with the governments of some member states to convince them that these are products which could also be used as biostimulants. The problem with them is very often that phosphates are, of course, also used in plant protection products. And so the multiple use or dual use or principle must be considered and must be taken into account, which some authorities have the problems with. Then the fourth point, REACH Plus, is something we deal with currently very much within EBIC. The fertilizing, I mentioned that earlier as well already. The FPR imposes requirements for chemical substances used in fertilizing products that go beyond normal REACH requirements. And the example I wanted to give you is food colorants. Food colorants are very often used in biostimulants. They are used in fertilizers. And these colorants are very often used for end users to distinguish products between each other. When they use different granules, they can easily distinguish, okay, wait, the blue one is the NPK fertilizer, the green one is something else or whatever. So the colorants help. Still, food colorants usually do not have to be REACH registered because they are already tested under different regulatory frames. Because for food you have even more strict regulatory, even more strict regulatory frame. Sorry. So they are exempted from REACH registration, but the FPR says all ingredients have to be REACH registered. So in this all, at least for CMC1 ingredients, also covers these colorants. And we are currently trying to convince the European Commission that this is really nonsense. When a certain substance is already tested, it is allowed even for food. Why should it be harmful to soil, for example? You know, that doesn't make sense to us. But that is just something which we will try to figure out. I just wanted to give you that as an example for things we are working on and struggling with. And the last one is digital labeling. Digital labeling is something we already started discussing when the first draft of the fertilizing products regulation came into play, because you always have that when you have a new regulation. Basically, the bureaucratic efforts will never reduce; they will always increase. And so for labeling, you have to provide much more information than you had to provide in the past, which means the physical labels you have to draw up, they are very extensive, and you have to bring all that information on the label. And in order to reduce the amount of different labels, manufacturers usually already use multi-language labels, which means you have more than one language on a product label. But the more information you have to provide, the more the number of labels increases. And this is where we started discussing with the European Commission that also in the sense of saving costs and energy and reducing plastic waste in the environment, it would make sense to provide much of the information in a digital label. And now the Commission said, okay, you can do that, or we will change the regulation in order to allow digital labeling as well. This is a longer process. They now came up with a draft, but the draft, unfortunately, although we mentioned that several times, does not distinguish between professional and non-professional users. With professional users, we mean people who use fertilizing products for a commercial reason. So they want to produce fruits or vegetables in order to sell them. And compared to non-professional users are, of course, people that use these products for their personal fun, let's say, in their own garden or whatever. And we understand that for people using the products in their home gardens, they need the information directly on the packaging in order to see and read what they have to do with the product. But for professional users, they know exactly what they use, they know exactly why they use it, and they usually have a smartphone, can just scan the barcode and see, okay, I'm looking for a specific information. But in this regulatory draft of the Commission, they did not make that differentiation. So in the end, that will probably lead to no change. Companies will keep on providing the information in physical form, since they never know if the product ends up in a professional or non-professional environment. And this is something which we also very much still are in discussion with the Commission. So now I have to come to the end, I think. The overall challenges for the plant biostimulant sector, there is often a gap between the EU's intention to promote soil health, improve crop production and the circular economy, and the practical aspects of regulations, as I hope I could point out a little bit. Regulators prioritized in the easiest cases, so the FPR has not provided access to many innovative products that are more complex, like animal byproducts, like microorganisms. And many plant biostimulants that improve nutrient use efficiency are currently not covered by the FPR. That's unfortunately a fact. What is EBIC doing currently? We just recently released our midterm strategy, which covers the years 2023 to 2027. So we do this every 4 years, that we sit together and find out and agree on our common goals for the next 4 years. And what we agreed on this time is, first, we want to enable the development of the plant biostimulant business in a harmonized European market. We want to enable global business development, so also on a global level. Biostimulants are not regulated everywhere worldwide. We want to position EBIC as an effective thought leader and influencer, and we want to leverage the EBIC culture, which we are quite proud of. And this is something which I wanted to show you. We have, of course, different project teams within EBIC, and we have the so-called project team on agronomy. What you see here is our strategic goals for this year with the different objectives. And what is interesting, I think, for you, since I'm in a researcher's environment here, is that we also have an objective which deals with research. We want to have researchers addressing key data gaps to strengthen the empirical basis for EBIC advocacy. That is, for example, develop a wish list of research topics for biostimulants and promote a European research project on the integration of plant biostimulants into modern crop management systems. That would be our wish list to research. Yes, and where is EBIC connected? Let's start above in the middle. I will just very, very briefly go through this. We are, as EBIC, observers to the Commission Expert Group on Fertilizing Products. That is the group working with the FPR, trying to find bugs and problems and trying to find solutions for that. We are an observer as an association. The main participants there are the European Commission and, of course, the governments or representatives of ministries of the different member states. We are further also observer to the coordination group of notified bodies. That is also a group led by the European Commission, but there are the so-called notified bodies in there trying to solve the problems which they have in practice in conformity assessment. We also observe this and also try to help solve issues. We are registered stakeholders with the European Food Safety Authority. We are in collaboration with national industry associations. We are partner of the Biostimulants World Congress, the main scientific conference for plant biostimulants. We have the code of conduct, as I mentioned, that every member has to commit to. We are in a liaison status with the European Committee for Standardization, the CEN, I told you. We are, of course, also as an as an association, as an industry association listed in the official transparency register of the European Union. Yes, the Biostimulants World Congress coming up in 2023 in partnership with EBIC from 29th November to 1st December. If you are, anybody of you is interested to go there, it will be in Milan this year, and you have the possibility to register for that in person or for digital attendance. And there are reduced registration fees for students as well. And you can find more info following the link below. I will, of course, if you wish, share that presentation with you. And in conclusion, it's just left to say, in just 10 years, plant biostimulants have become an essential tool for efficient regenerative farming that sees soil health and food production as intertwined goals. However, regulatory barriers remain for some of these products to gain access to market. And you can, of course, learn more about how plant biostimulants work together with mineral and organic fertilizers to optimize plant nutrition and soil fertility following that QR code or link. And now I'm finally done with my presentation.
Thank you very much, Thomas. Suye, you want?
Thank you, Dr. Leppin, for giving an extensive and elaborate stepwise description about how the FPR is working and how the biostimulant has to be registered and brought to the market. Most of them, some of the slides are very new for us, and we got a good information about that. I would like to ask first the students to ask the questions if they have anything, and then we can see. So, is there any students who wants to ask any specific questions?
When the fellows have no question, I would like to ask Thomas if there was ever a discussion about that plant species will be accepted as a biostimulants.
If plant species, could you
Yes,
help me understand a bit better?
Yes, we know when we grow a certain species beside wheat or maize, then we have a significant impact on the stress reduction, per example, or nutrient uptake by the root
exudates. Yes. Exudates. Okay.
Yes, and so it's when you accept microorganisms, why you don't expect up to now plant species?
Basically you do, but it's a matter of you probably think about growing these plant species, and even co-grow them, to have on one field two different crops growing at the same time. So you have the root exudates, which also help the other plants, for example, increase nutrient uptake or whatever. That is from the perspective of the biostimulants, or even from the FPR. This is not considered a fertilizing product as such, or it's not considered a biostimulant, because biostimulants are always something you externally apply, like a liquid or a granule or whatever. Co-growing plants would not, by the definition of the fertilizing products, be a fertilizing product. But this is, I understand where you're coming from. I completely understand. I don't know if you saw that I dealt with that myself in my PhD works with phosphorus mobilization from the soil to by plants which are able to exudate like protons or enzymes or whatever, for example, white lupin. But this is really something which is not covered by the FPR.
Okay, thank you.
Dr. Leppin, I have a question there. This is regarding the mode of action of biostimulants, okay? Because at this current, if you see the scientific articles, a lot of articles in the new publications, which has been showing the mode of action of different biostimulants, taking some model crop species like your Arabidopsis, okay? So there are in-depth studies nowadays published, and why the FPR is not looking at that type of studies or studies?
The FPR, yeah, basically the problem is it's always nice to have trials with Arabidopsis. They are, they are very useful model plant, and the use is widespread in science and scientific trials. But the problem is for practice, the FPR always wants to see, or let me say not the FPR basically, but the standards especially, they want to see that that this also has a relevance for practice. And so they always ask for trial results for crops that are also used in practice. In our discussions within CEN, it became clear quite easily that Arabidopsis was even actively excluded. Everybody said, no, we cannot accept trial results for Arabidopsis because that does not have any relevance for practice in the end. It's so far away from apples or berries or maize or whatever that it's not doable or acceptable.
Okay, thank you. Regarding the phosphites, yeah, you told that at this moment the phosphites are excluded or it is under consideration. Apart from the benefits like biotic stress or the pathogen stress, what you're telling there, is that the issue is that the phosphites also has some residual effect in the plants? Because I heard I read some articles and it shows that residual effect.
Yes, you hit the nail on the head. That is, of course, also an issue which must be solved. Basically, we see that, or we know that phosphites have a biostimulant effect. We know that. There's also scientific proof for that. But on the other hand, of course, and that's more a regulatory topic, there are so-called maximum residue levels defined for phosphites. These were, of course, included in a regulation since phosphites are mainly used in plant protection products, and you have these residue levels for them, but only defined for certain crops, because you can apply plant protection products only on the specific crops they have an approval for. So you cannot use plant protection products just for all different kinds of crops. But for fertilizing products, that is of course different. You can use fertilizing products for all different kinds of crops. You are not limited to just certain crops for which there is a defined maximum residue level, and that of course gives legislators a headache. So they say either we have to now define maximum residue levels for all different kinds of crops, or we have to find another solution to do this. But this is, from our perspective as EBIC, this is just an issue which needs some thought, and this is possible to solve this issue. This should not be a reason to keep on excluding phosphites from the regulations, since it is sure that they have biostimulant function, and the Commission already confirmed that they expect and support the multi-use principle, which says one substance can be used as a fertilizing product as well as a plant protection product at the same time. So you also have that. You can also use the example of copper. That's basically the best example which you have. Copper is a nutrient. It's a trace element for plants, plants use that, take that up. But on the other hand, copper is also very often used as a fungicide. So it already has two functions. So why accept copper but not phosphites? That is the question we ask then.
Okay, I have one more question, like about the microbial biostimulants. Yeah, at this moment only 4 of them are approved. If we have something that is new, is there any specific protocol that has been already there?
No, not yet. This is what I meant. You have only 4 of them approved, and the Commission is still working on kind of a protocol or a process in order to get more microorganisms into the regulation. But this is not yet even developed. This is what I mean when I say, they focused on the easy wins so far, and didn't tackle the bigger topics. And the bigger topics, for example, are microorganisms or animal byproducts. These are the topics which are not so easy to solve, and they have to come up with a whole new process, or as you said, with a whole new model to do this.
Okay. Thank you.
I wanted to ask something. Thank you, Thomas, for your talk. So, is there any kind of a worldwide or global strategy to harmonize all these criteria, that we have in Europe? I mean, there are different councils, I guess, depending on the country, outside Europe also. And is there communication between all these councils going in the same direction? Because you can have completely different situations. Otherwise, like, for example, with phosphates, that they could be approved in one place, but not in another one. So on.
Yes, Vincente, of course. I think you mean a collaboration between the different associations on a worldwide level. Yes, there is. At least I know that within EBIC we are well connected, for example, with the US biostimulants council there. And we are also sharing information about how the European fertilizing products regulation now works on biostimulants. They also share the same definition of biostimulants. So this is also what I meant when I said that is one of EBIC's midterm strategies, that we try to help the global biostimulants business increase. We need a common regulatory frame, or something which goes in the same direction, so we have the same opportunities around the world, and not have only a biostimulants regulatory frame here in Europe, but everywhere else it's still lacking. That is, of course, something we don't want.
Mm-hmm. Is it Europe the most restrictive one according to regulations, or?
I cannot really say this. I cannot really tell, because, of course, I'm very familiar with the European one. I'm not so familiar with others, but I would say we, of course, have some restrictions. That might be due to the principle we follow here in Europe. We always try to avoid risks by regulating upfront. In the US, they do this the other way around. As you might know, they regulate things when there are problems, not before there are problems. So it might be that we are more restrictive in one or the other way. But who is more successful with that, we will see later. I'm not sure where this is going.
Okay, thank you.
Dr. Leppin, we have one suggestion also from our side, actually, because as from BioAtlant is involved in EpiSeedLink. As you know, this EpiSeedLink project has a lot of objectives here. Some of the objectives also has to create a mode of action for biostimulants. Okay, and to understand the mode of action, always it is good for the scientists to use Arabidopsis as a model. Yeah. So there are extensive studies that is going to happen in EpiSeedLink in Arabidopsis also. to crack the mode of action of biostimulants. So our suggestion is that yes, trial data is required for product registration. Of course, I think we can use as a backup of this.
Suji will continue directly then with the next presentation, I think.